In this video, we are going to take a look at one more example of Green's theorem, and this one is going to be a triangle curve. Let's take a look at what it looks like. The curve starts at 0, 0, then it goes to 4, 5. So 4 here, 1, 2, 3, 4, 5 over here. All right, so this is going to be 4, 5. Then it's going to come back to 0, 5, so it'll be here. And then it'll go back to 0, 0. Now, the first thing we do is check the orientation of the curve when we're dealing with Green's theorem. Is it going to be counterclockwise or clockwise? If it's counterclockwise, we call it positive orientation and we do not have to switch the sign. But if it's clockwise, it would be negative and we would have to switch the sign. It looks to me like that's counterclockwise, so we do not need to switch the sign. All right, now let's take a look at the partial derivatives. So if p equals negative 1/5 xy, when I take the partial with respect to y, I get negative 1/5 x. Okay, if q equals that square root, which looks very, very complicated. However, because that square root does not have variable x in it at all, the derivative of it is just going to be 0. And then when you subtract them, so this will be 0. This will just be negative 1/5. Negative 1/5 x. When you subtract them, you would get, now this is supposed to be p, not f, well, whatever. Okay, so this is 0 minus 1/5 x. So that would be positive 1/5 x. Okay. All right, now we want to set up the limits over this triangle. So let's recall how to do that. Okay, this is going to be a double integral, and I'm going to treat this as a region of type 1. It actually will probably be easier to do it as a type 2, but since they want dy dx, I guess we are forced to do it type 1. The reason why I'm saying that it's easier to do that as a type 2 is because the left curve here, like this would be left, this would be right. The left curve is the vertical line x equals 0. So it's always better to that when one of the limits is 0. But oh well, it didn't happen here. Okay, so let me just erase this. It's not there. Okay, so the outside limits are going to be the x limits, which is the extreme values of x, and they change from 0 to 4. The inside limits, and again, we're integrating 1/5 x. The inside limits are going to be bottom curve, which is this orange one, right? We'll call it B, to top curve, and then this is top. Okay, so that's T. We need to come up with equations of each of those curves. Now, these are not going to be just numbers. Maybe one of them will, but not both, because this region is not a rectangle, it's a triangle. All right, so the top curve is actually easy because it's a horizontal line at the level of 5. So this is going to be y equals 5. So I already know that my top limit is 5. The bottom curve is going to be a line, and the equation of a line is y equals mx plus b, unless it's a vertical line. But in this case, obviously, the orange curve is not vertical. To find the slope, we do rise over run, right? And also look at whether the line goes up or down. This line goes up, right? If you're going this way from left to right, the line is going up. So the slope is going to be positive, and it's going to be 5/4, right? Because rise is 5 and run is 4. So that'll be 5/4 x plus b. But here it's very easy to see that the y-intercept is really 0. If you weren't sure about that, you can plug in 0, 0, 0 for x, 0 for y, and you immediately will see that b equals 0. So that's just 5/4 x. All right, so now integrating that should be pretty easy. You cannot, though, split because the limit, one of the limits has a variable in it, so that is not possible. So we will have to integrate it the normal way. So let's first integrate the inside integral. That'll become 1/5 xy. And when you substitute the limits, it's very important to put which variable you're substituting for. Because I was integrating with respect to y, right? And treating 1/5 x as a number, I multiplied it by y. And I'm going to be substituting for y to get the inside integral. Okay. So that'll become, I don't think I need this anymore. All right, so let's just finish integrating. So this is 0, 4. I will get 1/5 x. Now I'm plugging 5 for y, and then minus, same thing, but plugging 5/4 x for y. Always simplify if possible. It certainly is possible before you start integrating. So this will just become x, and this becomes 1/4 x squared. Okay, so now we're down to just a single integral, and it's easy to compute that. Let's see. Okay, so I'm already integrating. So integral of x is x squared divided by 2. And then x squared is x cubed divided by 3. I'm substituting 0, 4. When I substitute 4, I get 4 squared over 2 minus 1/4. And then here would be 4 cubed over 3. So 4 squared is 16 over 2, that's 8. And then 4 cubed over 4, that's going to be 16 divided by 3. Okay, so this looks like this would be 24 minus 16. I think that would be 8/3, and we are done.